Hello students, welcome to this session. So it's been it's been a very long gap that I didn't upload any of the videos. So I'm very sorry for that. From now I will be very consistent and I will be continuously uploading the videos, and mostly the videos will come every week, twice or thrice. So we will be starting up from each chapter and we'll cover all the level of concepts that has been there in that chapter, and we will go day by day, like we will increase the level and we will go till NEET level as well. Right, so today I am going to explain about the development of atomic theory. In the last session, we already have discussed about the cathode ray tube, Dalton's atomic theory, discovery of electron, discovery of proton, etc. And also, so in this session, we will be discussing about the development of atomic theory. Right, so what is an atomic theory and who was the scientist that came forward to explain about this atomic theory? Okay, so the atomic theory. So what we will be learning in this chapter, like in this session? So who was the scientist that came forward to explain about the atomic theory? So how atom consists of and how this atomic model has come. So we already know that how as an atom consists of. Atom consists of electron, proton and neutron, right? So you very well know that electron, proton and neutron. So and the nucleus is in the center, right? This is the center, and the combination like protons and neutrons, these two are present in the nucleus. Okay, when combinedly you call it as nucleons. Okay, what is it? You call it as nucleons. Okay, and what is this orbit? What is meant by orbit? Orbit is path of electron. Okay, so the path of electron. So where does the electron revolve? We are saying that electron is revolving around the nucleus. So where does it revolve? It is revolving around through the orbit, right? So how does an atom look? How atom looks? Atoms looks like a circular spherical. Okay, how it looks? Circular sphere which has all subatomic particles. So it has been looking like this. Okay, right. So atomic models, so that there were the scientists who came forward so to explain about the atomic model. So one is J.J. Thomson, and other one is Ernest Rutherford, and the Bohr's model. So you can say that not two, they have told three of the scientists. Okay, J.J. Thomson, Ernest and Bohr. So they have explained their own way of explaining about the atom. So what are the theories? What are the atomic models? So first one is Thomson model of atom, and the scientist discovered is Thomson, and next is Rutherford model of atom. So the scientist who discovered this model is Rutherford, and Bohr's model of atom, the scientist who discovered or who explained about the atomic model is Bohr. Now in this session we will learn about Thomson model of atom. So we call it as J.J. Thomson model of atom, and he is the scientist. He is J.J. Thomson. Okay, so he is J.J. Thomson, and how he explained this atom model we will learn it now. So Joseph J.J. So what is the full name of J.J. Thomson? Joseph John Thomson. He was a British physicist. Okay, he is a British physicist, and he won the Nobel Prize in the physics. Okay, and he is the scientist who studied about the electric discharge tubes, right? In the last class, in the earlier classes, we learned about cathode ray tube, where in that discharge tube, with the help of the discharge tube, we have learned how the electron and protons and neutrons are discovered. Okay, and he got the credit for the discovery of one of the subatomic particle, that is electron. Okay, so this electron was discovered by J.J. Thomson also. Okay, who discovered the electron? J.J. Thomson. So he got the credit of discovering that subatomic particle, and he won the Nobel Prize in the year 1906. Okay, and is recognized for the experimental investigation of conducting electricity by gases. As you know that in the discharge tube we will be passing the gas, that is hydrogen gas. Okay, so to the hydrogen gas he passed the electricity. right? He passed the electricity. So for that reason, he won the Nobel Prize. Okay. Next, so Thomson model of atom. So earlier there was the other scientist. This model first came in the year 1897. Okay, and they couldn't explain any of the atomic model, and it was being like that. And later Thomson came, and in the year 1900, the J.J. Thomson has proposed this theory and explained what exactly is present inside the atom. So what contributions, like what Thomson has discovered? What is the contribution? He told about the discovery of electron, so which by the help of cathode ray tube, the discharge tube, we have learned it in the earlier class, right? And next, this Thomson, he explained this atom, how the atom is present with the help of plum pudding or watermelon model. We also call this J.J. Thomson model of atom as watermelon model also. He also explained the mass spectroscopy and isotopes as well. Okay, so discovery of electron, you know, here we will be passing out here we have the gas, hydrogen gas, and there we have been passed the electricity, right? And by passing out the rays from there, we have discovered the electrons, right? So this is how the electron was discovered, and that electrons, right, and an atom is made up of very small particles. The positive charge is uniformly distributed in the atom. So after the electron and proton was discovered, they told that J.J. Thomson told that he has explained his theory by taking an example of plum pudding. So you know that this is a plum, right? So whatever the plum is there, okay, plum, the plum part, it is consisting of positive charges, and the puddings in the sense you have tutti fruttis, all the dry fruits which you added in the plum, so those all are of electrons, right? Or you can say that this, whatever the red part in the watermelon is there, that is consisting of positively charged. That means the whole atom is consisting of the positive charge, and in the positive charges the electrons are embedded. That means in the positive charge in the atom, the electrons are embedded, like this. How the seeds are embedded in the watermelon, the same way the electrons are embedded in the watermelon. By this, this model helps us the visualizing the puddings. Okay, so that is in the puddings the positive charges, and the plums are buns or negative charges, right? So we can also compare it with the watermelon. As I already told, we can also think of a watermelon in which the positive charges in the atom is spread all over the parts, right? It has been spread all over the part, while the electrons are studded in the positively charged sphere like seeds. So that is the reason we call this the Thomson model as watermelon model as well. So what is the mass of an atom? So where does the mass of an atom and how it is calculated? So mainly the mass, any object you take, the mass will be present in the center. Okay, so now as it has been positive charges, the mass is being, center is what? In the nucleus center we have positive charges, and we are saying this positive charges are uniformly distributed in the atom, right? So that means the mass is something where we calculate for the complete atom, right? So you don't get confused. You can say this whole part is there, this whole atom is there, the positive nucleus in center is the nucleus. In the nucleus you are having positive charges, but these positive charges are uniformly distributed. So that means the positive charges, the whole mass is being uniformly distributed to the complete atom, right? So this is the very important feature which was being told by J.J. Thomson. Right, so in this session what we have learned, so what is an atom, what are the particles has been present, so how he named the Thomson model as a plum pudding or watermelon model, and positive charge in the atom is spread all over the watermelon red part, where the electrons are embedded in the positively charged like seeds and watermelon, and the mass to the atom, the if you want to find out, or if you want to calculate the mass of an atom, that means the whole atom mass, that means whole number of protons, whatever is being present, that will be the mass of an atom. I hope you understand the session. We'll come up with the more videos, and next we will be learning about the phone model. Stay tuned.